Thanks for joining today, everyone. Today's webinar is going to be held and hosted by Esri and UIGA. My name is Todd Hagan. I'm with Utility Inspection and Geospatial Alliance, and we're excited to have a panel today where I think you'll really enjoy and learn some things new in this space. For those of you that may not know, the Utility Inspection and Geospatial Alliance was founded in 2021 and really covers these four areas, being asset inspection, vegetation management, storm response, and wildfire mitigation. Here's some of the different participating utilities. And in a short while in August, we'll be going to Southern Company, who will be hosting our summer event. And we hope that those of you that might be interested, please reach out to us if you're interested in attending that and seeing what Southern's up to. I want to say a huge thank you to Esri, who's our exclusive geospatial partner. They've made today's webinar possible. And then before I turn things over, I'll share information. I'm Todd Hagan. I'm one of the co-founders here at Utility Inspection and Geospatial Alliance. My other co-founder, Ken Manis, you'll see his information there. And then the last housekeeping item is that if you do have questions during today's webinar, we'll be answering those at the end. Please put those into the chat area on the display, and we'll be sure to get answers for you. And if we don't have enough time, we'll follow up with you afterwards. That's it for me, and I'm going to be turning things over to Tom Lenzen, who will introduce today's panel.
Thanks, Todd, and thanks to Ken. And a big thanks to all the operators and vendors that are part of this community. This is a very exciting time in our industry, to be sure. So today we're really excited to have a couple of our longtime customers, Great River Energy and Dominion Energy, who are going to present on some of the things that they're doing around leveraging oriented imagery and AI workflows to support asset inspections and audits, which is the topic for today. Again, this is one of a four-part series that we're doing, where we're just talking through common practices for operations in this space. So we're excited to have Joanna Bristol from Great River Energy, Carson Menzel from Dominion Energy, and Joel Bernstein from Noteworthy, who's working with Dominion Energy as part of our presentations. And then myself, Tom Lenzen, and Cody Welch, our lead solution engineer for utilities, will be providing some foundational information to start this. So a key theme that we're talking about today is, and that we're seeing in the industry, is enabling your organization with ArcGIS to support the geospatial requirements around asset management and maintenance. Esri has been providing solutions on this around this kind of business requirement for many years. We have organizations that have been storing imagery for the last 30 years as an attribute or an asset associated to an asset in the field. So we're excited about some of the new innovative ways that people are leveraging new technology, drone collected data, those kinds of things to support this specific business area within utilities. The key theme that you will see today revolves around acquiring, managing, and applying data to support those business needs. So there's really, for today's session, there's probably three primary themes that we want to make sure that you take away. One is there's many new innovative approaches with imagery, lidar, new thermal sensors, all sorts of different tools that are being applied in the electric industry to asset inspections, asset conditions, facility monitoring, and ultimately 3D digital twins and living digital twin. The interesting part about that is we're seeing significant improvements in efficiencies in terms of the methodologies and workflows that are being leveraged to do this work. And it's providing a very very nice foundation for the things that you want to do in the future. The second point is really around if you think about what you will be doing for the next 10 to 20 years around automated intelligence and mapping and AI types of activities, this sets the foundation. So a very accurate representation at the beginning of this process provides a solid foundation for you to do your work as you move forward with this technology. And then the last thing is really leveraging the technology that you already, in many cases, have within your organization to do this work. Many of you already have many of the tools and capabilities that we're talking about today. So those are the three main themes that we want to make sure that you take from this. With that, I'm going to pass it over to Cody Welch.
Thanks, Tom. And thank you all for being here today with us. We're really excited to show you some of the great work that our colleagues are doing and help provide some ideas about how you can leverage this technology on your end as well. So to start with this, what is oriented imagery and what is that capability within ArcGIS? Fundamentally, oriented imagery is the capability to use metadata inside of images to capture the image's location and orientation so you can see in relationship where that image was taken to a map or a scene. It's essentially the concept of if we know where that photo was taken and the direction that it was looking at, we can calculate where each pixel in the image would be in a given map or scene. This can be done whether we're using have street level imagery, obliques from drones, aerial platforms, 360 images, or any type of imagery from the mobile device. You can visualize and explore these in full resolution with all that geospatial context that you have inside of your GIS. You can also take this and make it accessible throughout your entire organization. So anyone can easily search and discover all of these images, whether that be at a specific site or an asset. And this capability is core to ArcGIS. So you can leverage this in our desktop platform, web, and mobile applications. So what does that look like? Here in this example, we have an ortho over our substation. And as we click our assets within that map view, we see that source frame load up next to it. So like I just mentioned, we're able to actually access that high resolution image and see what the drone was seeing when that image was captured and see the X in the map along with it in that image provided beside it. Because this data is accurate, we can actually take that metadata and do additional things like measurements like we saw right there. We can provide additional layers such as overlays or other asset information that we may have like we see here. And not only do we see that in our map space, because we're working within this oriented imagery viewer, we can turn those same data layers on inside of the viewer as well. So here we see our control points, those building features that we were just looking at, and all of that ancillary GIS that you may have within your system. But we're not just limited to doing or in viewing features that we already have. We can also take this same data model and do traditional workflows that we're already familiar with, such as drawing and annotating right there in the image space and see that populate in our map. So say we want to tag this asset, we can do that within the image, save it, and it is then populated in our map. But we can also do this in 3D too, and pair it with all that 3D context from your captures that and those derived products that you may be making. So in this example, we can see that same field of view. As we zoom into our source frame, that frustrum or that red cone refines down to where that sensor was looking at. And as we move across the image, we can see that pan with it. We can turn those on and off. And we can even do triangulated distance and area measurements because we're exploiting that metadata that's underneath it. So that means that we can measure against the top feature in that image and do it again in the secondary image to calculate a value and see how they are relative to each other. from 2 of the raw images that we collected using this drone to model out this same image or this same project area. This is truly by definition of collecting once and using many different ways. And then lastly, we can compare that with our scene tools so that we have a given reference point between both of our images and the scene itself. So it's really important that we see this because that shows us what this data model allows us to do. But remember, accuracy matters. So what you can do in these data models or these oriented imagery data sets is all reliant upon the metadata within inside your imagery. So if we have low precision metadata, it's easier to interpret imagery within the GIS, it's cheaper. However, our visualizations are less accurate. So like we just saw with our measurements, that may not hold true if we were to use low precision metadata. However, if we enhance that and make it high precision, that improves the accuracy, it has ready to use metadata, and it can support some of those advanced features like we saw with the triangulated measurements area and so on and so forth. If you wanted to improve your metadata, we have tools within ArcGIS to do so. You can use RTK or PPK systems, a higher end camera, or even leverage photogrammetric processing to help refine all those values and make them more actionable for downstream analysis. So with that, I just wanted to provide an overview of what this capability is. And now I'm going to pass it over to Joanna for her to showcase what she's done with this capability in action from her organization. And thank you again for being here with us today. Joanna?
Thanks, Cody. All right, so today I'm going to be walking through how we have been improving structure inspections by changing the way that UAS imagery is captured, organized, and viewed within GIS. So to provide some information about who we are and the perspective that we bring, Great River Energy is a generation and transmission cooperative. We serve 26 member owner co-ops across a very largely rural service area in Minnesota. We serve approximately 1.7 million people and maintain over 5,000 miles of transmission line and nearly 70,000 structures. So while we aren't the largest utility by any means, we do have a vast surface area to maintain. And this is a big part of why we are evaluating more efficient ways to capture and use inspection imagery. The practical problem is that we do have lots of aging high voltage infrastructure from K69 to 500 kV. And this is spread across largely rural areas. And with this, many of our assets are located in remote or hard to access terrain. With traditional ground-based inspection, it is both time-consuming and potentially risky for crews to get to the really remote structures. Additionally, a ground-based inspection means that you're inherently viewing some of the critical components from limited angles. Even when using binoculars, there's just certain things that cannot be seen from the ground. So the beginning of this year marked the start of a pilot program for us, in which we've been evaluating how a UAS and GIS joint approach can help improve this process. To do so, we have been using the DJI Matrix 350 RTK and utilizing our BV loss waiver to perform inspections. As part of this process, we have a lineman and a UAS pilot in the field working together to take both nadir and oblique images at each pole that needs inspection. By getting multiple angles and multiple shots per structure, we ensure that the entire pole is reviewed. We've been able to get extremely close and detailed visibility of things like insulators, crossarms, cotter pins, and the overall structure condition. It has allowed us to inspect parts that cannot be seen from the ground. In a lot of cases, we're capturing imagery of components that haven't been seen in many, many years. Now, since the drone is faster and we can go much further, especially when we're flying beyond visual line of sight, UAS inspections are substantially faster than traditional. We're covering more ground in less time, at the same time preventing crews from having to trek out to some of those really remote assets. And most importantly for me as the GIS analyst, each of these images is geotagged and it's rich with camera metadata information that post-flight we are going to extract. This information is brought into GIS and made available to enable further inspection and review, which is really the point and the bulk of this presentation. So moving beyond capture and making this imagery actionable, I developed a script in ArcGIS Pro, which uses multiple ArcPy functions, which automates the process of getting drone imagery into GIS as a feature that can be viewed and sorted. I will be displaying a video demo coming up here, and that's going to explain this in more detail. But to provide a general overview, the script works by taking a folder of geotag photos, it converts them to a GIS point feature, adds the photos as attachments. Next, and most importantly, it automatically calculates which structure each photo is associated with based on the distance and camera direction. And it then brings over structure attributes like the structure's asset ID, name, pole material type, voltage, and other key attributes. Next, the script generates line features that indicate what direction the camera is facing when the photo is taken. And immediately after the script runs, these features and photos are made available within a web experience that we have built. So this whole process takes about a minute, and within that, we have a catalog of inspection imagery that's now geolocated and identified to its appropriate structure. So now I'll be playing a demonstration video I have that will dive deeper into how this whole process works, why the script works, how it's more efficient, and give some examples of the outcomes. Now, we did notice the audio does play a little bit soft, so go ahead and please turn up your volume if need be.
Today, I'm going to be doing a quick 5-minute demo of a script that was developed to make it easy and repeatable to take geotagged drone photos, bring them into GIS, and
The audio stopped for some reason.
Did it?
automatically
Okay.
connect them to structures.
I'm gonna go ahead and
Today,
restart.
I'm going to be doing a quick 5-minute demo of a script that was developed to make it easy and repeatable to take geotagged drone photos, bring them into GIS, and automatically connect them to structures. Traditionally for us at GRE, getting drone photos attached to features in GIS was a very manual process. Photos live in random folders or SharePoint, they're not spatially connected, and it can require a multi-step process to add the images to the correct asset, which makes it harder to view, filter, and actually use the imagery for decision making. The script I'm about to show eliminates this manual process of adding attachments to GIS features. This script was developed as part of a pilot structure inspection program that we began this year, in which we capture multiple UAS images per pole, and we needed a way to see each image easily and know which it is. So let's get into what this script actually does. So we are going into the toolbox, and the input that you are going to select is a folder which contains geotagged photos. I've also configured it so that you can add additional comments if you would like to attribute that to that set of photos. So I'm going and running the script, and I'm just opening this up so you can view the details. So high level, what this script is doing is it's converting geotagged photos into points, which is a basic ArcGIS tool. Then it extracts the EXIF information like the location, the camera's direction, the drone's model, and then it creates a viewing line, which uses the bearing and distance. So it knows exactly which way the camera was facing when it was taken, so you know which side of the structure you're actually looking at. It then spatially matches the photos to nearby structures and appends everything into existing GIS layers. So as we see, this script is almost done running, and we're going to let this continue to go. And as you see these messages that pop up, it indicates exactly what's going on behind the scenes at the time the message shows up. And there we have it. So that's done, and the total time that this script took to run was 48.39 seconds. So quite a bit faster than doing this manually. So I'm going to zoom in here so we can see exactly what it looks like. All right, so what the script has done here is that it has created a point where each photo was taken, as symbolized by the little orange camera, and it has also created a line which indicates the direction that the camera was facing when the photo was taken. So let's go ahead and look at some of the fields that the script has populated. It has the folder name, so which folder the photos were in, the name of the photo itself, the nearby structure, nearby line, voltage, structure type, the viewing direction, the drone's model, the comments field, date time, and a bunch of other additional fields. And another point I want to kind of make about this script is that it was designed so that this workflow is repeatable. So each time we want to add new imagery, we can run the same script and it's not going to rebuild or delete any existing data. So it's set up to use a temporary feature layer, which will stage the new photos and then append into the target feature class. This way, we're not creating new points and rewriting data that's already been run through the script. Another point that I wanted to make is that I developed this script with zero prior Python experience. I was able to use Esri documentation along with Microsoft Copilot to develop this script, which I think is really inspiring because it shows that scripting is quite a bit more accessible and doable than it may have seemed in the past. Now we are going into the web experience side. So as we need a way to actually view these images, web experience was an excellent solution. So I'm scrolling on the right so you can see that these are all the images associated with the map. So it's extent based. So as I zoom in, the number of pictures that can be shown are limited to what is being shown in that map extent. So we're going in here, just looking at, you can make it a pop-up. So I have it set up so you can go in, open another tab, and just make it really easy to perform these inspections by zooming in. And you can see at the top, there is dynamic text attributed to this. So as soon as you select an image, you're going to get those attributes to show up. And then I have also built in a filter. So that's what I just selected there. Change the line name. So now any of the points that are shown and the images that are shown are only going to be associated with that particular line name. And again, here we go. You can just see the quality of these images and just the ability to be able to see exactly which way they were looking when the photos were taken, and to really get in there and zoom in. But web experience has really been extremely helpful because it enabled us to add additional spatial context to the imagery, to be able to zoom in, filter, add the dynamic text. It all attributes to better situational awareness, and it helps us to prioritize where maintenance needs to occur by looking at these images, and helps us to maintain a consistent inspection photo inventory. So to wrap up, really the structure photo script and its web experience really represents a repeatable and scalable approach to bring drone imagery into GIS in a way that's immediately useful. It not only enables extremely fast visualization, but it's just built a strong foundation for our structure inspection program going forward and has inspired us to look at using scripting for suiting other imagery needs.
Okay, so what I hope was gathered from that demonstration is the fact that imagery is powerful. What this pilot program for us did was really turn drone imagery into something operational. It's not just a collection of photos, but it's actually a structured inspection record that's tied to an asset. So rather than having TC&M crews spend time having to dig through multiple folders or SharePoint sites or just relying on field notes, they can open the map, select a structure, and immediately see all the associated imagery in context along with key attributes. For us, our organization was already very familiar with GIS, so using an interface like Web Experience was the obvious choice. It's already familiar to our users and it's already accessible. Makes it a lot easier than having to go to additional sites. And overall, this changes how inspections are reviewed. Multiple people can evaluate the same structure, they can revisit conditions over time, and make decisions without having to go back out to the field. And this just really creates consistency. Inspections are no longer dependent on who just performed it and just having to give, oh, I saw something. There's actually a shared visual record. And over time, this does build a historical data set of the structure's condition, which we can use to help identify trends, prioritize maintenance, and just support more informed decision-making. So from an implementation standpoint, this workflow itself, the concept is pretty simple. You capture imagery and you get it into GIS, but the impact really is significant. It reduces time spent having to manage imagery, it improves visibility into asset condition, and creates a repeatable process. So moving forward for us, the focus will be on refining our capture standards and making this process even more useful and automated. And with that, I will turn it over to Joel from Noteworthy.
Thank you very much. All right. Thank you everyone for joining this afternoon. I'm Joel Bernson, and I'm joined by Carson Menzel from Dominion Energy. We're going to be presenting on collecting asset visibility at scale, how you can build a ground-based baseline of your distribution grid with automated AI cameras and analytics. I'm the Chief Growth Officer at Noteworthy, and Carson is a business intelligence analyst. At Noteworthy, our mission is to improve reliability, resiliency, and safety of our grids. We do that by providing vehicle-mounted cameras that are equipped with AI and automated analytics that help utilities operate with greater situational awareness and ground truth visibility. Our company was founded in 2020, and we've worked with over 30 utilities and their industry partners. To do what we're doing, we have to look at a lot of distribution poles, over 1 million to date. That means that the models that we develop have been trained to perform across a wide range of situations and geographies, and we know that they will provide meaningful insights for any of our customers day one. We also know that no one is looking for another dashboard that they need to log into, so we've worked hard to build out a network of key ecosystem partners who we integrate with natively so that we're able to operationalize and contextualize our insights within the workflows that our customers are already doing. So one of the examples of this, one of our leading integration partners is our partners at Esri and their ArcGIS platform. We'll be covering a little bit more about that during the case study as well. At Noteworthy, we're putting vehicles and we're putting cameras and AI onto utility fleet vehicles. So as you can see here on the slide, we've got the camera on the roof of the vehicle there. We're automating the process to collect the data as well as the insights generated from those cameras and data with these cameras and the end-to-end system that we've built. You can do this at up to 65 miles per hour. So posted speed limits are perfectly fine to drive at. Everything's available near real time in our cloud as far as the results go. Everything operates fully autonomously, so there's no interaction by the driver, no operators required for the system, and you can put this onto your existing fleet vehicles. You just simply drive as you normally would at the posted speed limits. So whether it's routine operations, vehicles that are out every day in the service territory doing other jobs, and we're passively updating your visibility, or with dedicated truck rolls where we're trying to collect specific circuits and feeders at a high rate of speed. It's the most effective way to cover your service territory at scale. And ultimately, it's turning windshield time into actionable insights. So you're going to have windshield time with vehicles that are out in the field. If they're trying to collect data conventionally, they're actually facing a lot of safety hazards, having to drive slow, having to make frequent stops and get out of the vehicles. We're able to accelerate not only the collection, but improve the safety of those collection efforts, as well as make sure that whenever those vehicles are out in the field, they're bringing back value to the organization. Real high level on our platform, it starts with the data capture. So we have edge intelligent cameras that we're putting onto the vehicles. Those will upload data either via LTE or Starlink. That data is then sent into our cloud to provide analytics on the data. All happens automatically. We publish those in our Inspect Cloud app, which is available to all of our customers. They have a private single tenant environment for their organization. But we also have these native integrations which automatically deliver our insights into the environments that our customers are already using. And that's really where the true value to operationalize our data comes from. This is a little preview of what our cameras are seeing as they go down the roads. You can see in the center, we actually have a stereoscopic camera, has depth perception that's used to identify and geolocate poles as we're driving down the road. And then as we approach the poles that have been identified and geolocated, we take high resolution images of poles on both sides of the road with a 24 megapixel camera. We send that data in real time into our cloud for analytics. So within 5 to 15 minutes of driving past a pole, we've got those results available for review or delivery into those other systems we're integrated into. So with one single truck roll, one capture of imagery, we're able to deliver on a number of different use cases, helping everyone who's got a stake in maintaining poles be able to improve their visibility and optimize how they utilize the resources that they have on their team. So instead of having redundant truck rolls, every time we see a pole, multiple teams will benefit from that. So whether that's the GIS team, ensuring that there's accurate location records and asset records on the poles and the components of the pole, whether that's the team actually maintaining those assets, being able to proactively identifying emergent issues. We also do lighting audits, being able to identify things like LED or non-LED bulb types, the smart node sockets, day burner defects and things like that. We also look for vegetation growth on the poles, so helping proactively maintain the vegetation on the poles. Joint use attachments, being able to not only identify the telecom space on a pole, but how many attachments are on there for reconciliation and potentially collecting increased rent on those poles, as well as looking for stub poles and whether those poles have been vacated or not yet. And we also do damage assessment after storms and extreme weather events, looking at things like cutout statuses, cross-arm damage, transformer damage, pole damage. We're able to look at those from that moving vehicle at the posted speed limit and provide those damage assessments much faster, which ultimately means field crews can get out faster to restore power and provide also more accurate ETRs to customers. In this case study that we're going to present, Dominion, like many of our other utility customers, are deploying multiple complementary data collection methods to maximize their asset visibility. So the key to this is finding the right tool for the job. And by combining technologies, you can take advantage of the strength of each, increase your resource utilization, operational efficiency, and the overall program value. So what we do with our vehicle-mounted cameras is providing very highly scalable high volume collection during routine operations, and that allows you to have a frequently refreshed baseline view of your distribution assets. Drones are often a big component of these programs as well, and when you have that baseline visibility from the ground, those drones can then become much more targeted collection efforts, looking for multi-angle, very high fidelity perspectives. They are more resource intensive, so it makes it harder to scale at the same way that you can from the ground. And so by having a more targeted approach, you can get the most value out of the drones. Similarly, with a satellite-based solution, you can have a very wide macro perspective, and that can help you focus on more local data collection and remediation efforts. And then in addition, there's a number of different sensors that are coming onto the grid as well, providing always-on active monitoring for different conditions that utilities care about from a reliability and performance perspective. So all these combined can complement each other and play a key role in helping you get the visibility that you need to act more efficiently, as well as increase the reliability and resiliency without necessarily increasing the cost of operating your grids. So what we're doing at Noteworthy is we're trying to be the easy button to collect your distribution grid data at scale. We can collect thousands of polls per day during routine operations, and we provide near real-time actionable insights. And it's very cost-effective and scalable. By deploying these on your existing fleet, you're able to automate the collection, increase the visibility without increasing the cost. So we like to say it's maximized impact with minimalized resourcing. So we're continually refreshing that baseline for increased situational awareness, and that enables a more targeted use of your premium and O&M resources. So as an example, this is not any one specific utility. It's based on a number of utilities we work with. Just imagine this utility has about 1.25 million total overhead distribution poles and about 40,000 miles of feeders. With a drone program that they may be running today, they're targeting 5 to 10% of their poles annually, flying dedicated missions. Across that whole service territory, they may end up utilizing 80 to 100 drone pilots to collect that. In many cases, they're only getting drone imagery out of that program, and they have to do manual work to review the images. And then the refresh rate is variable based on how often they go and retarget those poles. It may be several years in some cases before that same pole is looked at again. And that falls mostly onto their O&M budget at a cost of about $8 to $10 million annually. In contrast, what we're doing at Noteworthy from the ground would be collecting 100% of their feeders as well as most of their laterals over the course of the year. We do dedicated collection to get a view of the baseline as quickly as possible. And then on an ongoing basis, those same vehicles are out every day in the field doing passive refreshes of the data. This program is delivered for the equivalent of one FTE, and it provides end-to-end asset intelligence. So not only imagery, but also the analytics. The refresh is on a continuous basis. Every time that vehicles are out in the field and see a pole, the data is refreshed on those poles automatically. And because this is an end-to-end solution based on our hardware, we're able to have significant capitalization potential of the program for under $2 million annually. With that, I will hand it over to Carson, who's going to share more about the case study from the Dominion side.
Hi, everyone. My name is Carson. I'm with Dominion Energy, specifically with the IMAP project. I'll be going over our case study with Noteworthy AI. Okay, a quick overview of our Dominion Energy. So we operate in Virginia and North Carolina and cover about 13,000 square miles of service, which is 2.8 million customers, about 31,000 miles of overhead distribution line, and 1.3 million distribution poles. Okay, IMAP. IMAP is a remote sensing, image management, and analytics program. Has a similar mission statement to Noteworthy AI. We want to enhance safety, reliability, and resiliency by using remote sensing data. So we've been approved for 3 pilots, and today I'll be specifically going over our vehicle overhead patrol pilot that we did with Noteworthy. The image you're seeing here is the 9 circuits that we patrolled. We wanted to make sure to get 9 circuits in a variety of different areas. So as you can see, we have some coastal, some mountainous there in the Blue Ridge and Shenandoah area, as well as rural and urban areas. Just to note, when we were doing these drives with Noteworthy, our hub is in Richmond, so we were driving from Richmond to get to these areas. It was really convenient to send Noteworthy a buffer of the area where we would be collecting. That way we weren't collecting 3 hours of polls on the way out to the Blue Ridge area. Also to note, we did use drone imagery in these areas as well. So we had quite a lot of overlap with the Noteworthy drive and the drone imagery, but like Joel was saying, it was great to have both for comparison, and then in future we could just be using Noteworthy and then drill in with the drone imagery for that higher level of detail. Okay, so going into specifics, we use the Noteworthy AI imagery for our asset inventory. We really want to work on our GIS conflation, make sure that we have our GIS mimicking what we have out in the field. So placement of poles, I'll go into results on the next slide, but we had quite a few missing poles. Insulated material type, it's a little hard to see the image in the middle on the top there, but it was getting, their AI was capturing our insulator type. So you can see that that was a porcelain insulator. Also unique, identifying idle transformers through their AI. So no surprise here, COVID has long ongoing effects, and our inventory has been not as abundant as we normally have it. So when we see an idle transformer that was picked up by Noteworthy AI, it allows us to note that and then remove that transformer and keep it as backup inventory. And the way they figured that out was if the transformer had an open cutout, which means it's just sitting there. Asset inspection, so their AI was able to capture polling, damaged assets. So I included very obvious noteworthy pictures of damaged assets. Like I said earlier, the drone gives great higher level of detail doing that top-down look. But I will say if a pole and an asset was extremely damaged, it was very obvious from the imagery we captured. So although it's great to have the drone as backup, we were seeing severely damaged assets just from the vehicle. And I included some images of a decaying pole top here and a splitting crossarm as well. Also lighting audits. So typically our street lights and our outdoor lighting team, we build contracts spatially. We have a couple contracts that are not built spatially, which makes doing audits very difficult. So separate from the IMAP project, our outdoor lighting team is actually really interested in using the Noteworthy vehicles we have to drive through the contract areas and get that automated street light, and then also the types. We build based on type as well, so it'd be good to know, the type LED or mercury vapor or anything like that. Also the day burner types like Joel said as well. And then joint use attachment. So we've been working closely with our joint use team, identifying double poles and the count of attachments. And like I said earlier, we do have quite a few missing poles. So if those missing poles have joint use attachments, that's cost recovery for us because that's also built through GIS. And then vegetation intelligence. This was really great and actually a really easy thing for our local offices to fix if it was vines. Tree encroachment's a little bit more difficult, but if we sent out some overgrowing vines to a local office, they could go out the same day most likely and cut the end of the vine and get that cleared up. Okay, fun part, results. So in total on those 9 circuits, we collected 3,315 polls, which equated to about 38 hours of driving. And that's including the transit. So I know specifically when we went out to the Blue Ridge area, that was, I think, 3 hours to start the drive and 3 hours back. And then same with some of the coastal, that was about a 2-hour drive just to start the collection. And then 700 unique polls per 8 hours, also including transit. Now asset insights, just to note, since we did do drone and noteworthy, there's a lot of overlap. So I do think these numbers might be higher. Just when I was going through the images, if we did have drone imagery, I was marking that as the inspection method. But these numbers are just noteworthy where we didn't have any drone overlap. So we had 456 polls. We had about 106 missing assets. So transformers, streetlights, some fuses and switches too. One thing we can't get with the drones is the polling. So polling greater than 7 degrees was 121 polls out of those 9 circuits that we collected from. 5 to 7 degrees was 156 polls. And then damaged assets, like I said, normally when we were finding damaged assets, it was pretty severe, pretty obvious from the ground. So we had 26 cross arms, 336 poles, 8 pole tops, and 61 transformers. I included 4 images of some obvious damages. We've got quite a bit of vegetation on this transformer pole here, severe lean, pole top decay, and then a splitting cross arm here. So additional value from these pilots, GIS conflation being a big one. So when going through all this data, we found a pretty clear correlation between missing poles and those poles having high and critical damages. So those poles, since we do not have them in our GIS, they're being excluded from inspections, preventative maintenance. We do pole inspections, transformer inspections, and not having them in our system, they're missing out on that. So that was pretty interesting to figure out. Another thing that's important with the GIS conflation is if we have transformers that are missing or even on an incorrect pole, that means the customer is gridded incorrectly. So basically, if that customer calls in an outage, our storm patrol and our RSD might show them in the system as not being out at all because they're gridded incorrectly. So ideally, we want to have everyone gridded correctly so that we can be dispatching crews to the correct location, which makes us have a faster response time to an outage and thus increasing our operational efficiency. Another great thing about Noteworthy is the user friendliness of their interface. It's very easy to use. It's also extremely easy. The easy button is definitely correct, but it's easy to send out information to our local offices. I included just a basic screenshot of some crossarm damage. It includes our grid address, our location, and then just a general idea of what's going on. And I can easily send that and email that out to the local office for them to look at. Okay, so some key takeaways. Noteworthy has been effective in passively and efficiently capturing data. One thing I wanted to note too is that we have been going to our local offices. We've done 2 so far, but we're checking in on the offices that we did pilots in and just getting responses back and having discussions with our operations, design, construction team and seeing how they like all the pilots that we've been doing and seeing what they need from us and things like that. And they all really like the Noteworthy AI data, specifically how quickly we can get that. The last office visit we just did, there was a specific question about sometimes we need to go look at an asset that day. We get notified that day, we need to go look at it. And they're talking about how quickly we can get the drone data when it might be better just to get the noteworthy AI data, because that pretty much when you get back from a drive, it's already there and already ran through the AI and ready for you to view it. Another thing too, more people are most likely to have a license to drive a vehicle and maybe not a drone or a drone pilot readily available. Noteworthy also maintains a high accuracy rate, simplifies the process of identifying missing assets and conflating GIS data, helps easily show and compile damaged assets, and enables easy distribution of asset information to local offices. And that's it for the pilot and case study that Dominion Energy did with Noteworthy AI.
Great. Thank you, Carson. I've been collecting questions and answers, and we have quite a few of them. So I'm going to rotate them across all you guys. We're going to start with Joanna, and we'll filter through and see how many we can get to. We have about 14 minutes here. So Joanna, if you're ready, we'll start with you. They were asking about if there's a GIS reconciliation process that keeps your asset data and GIS current upstream of this. So thinking
Yes.
of polls and the tendency over time for the true network asset locations to mismatch the GIS database due to maybe like pole replacements not being updated, etc.
Very good question. So we actually do keep these really quite up to date. Almost a lot of our poll locations are survey grade. So for the locations that are shown there, that's sub-foot accuracy for all of those polls. We do receive data from our survey crew, and we also do perform regular, like an ETL that pulls from our Maximo asset system. So we're maintaining those attributes.
Great. Okay. And next for Joel and Cody, no questions for you. But if you want to chime in as it relates, because when you find all these fun things, the first thing you typically ask is, where's that at? And so if you have something to chime in about it, please do. Joel, there was a question about, have you been able to train the AI model to be able to perform like a pass-fail inspection on joint use attachment inspections?
So what we're doing today is primarily focused on just the inventory side, as well as the stub polls and helping manage those. We do have a next generation hardware solution that's coming out. We're actually doing some projects with it in Connecticut with one of the IOUs in the state right now. And one of the uses for that is to improve their poll load analysis when they have new attachment requests. So we'll be able to do NESC grade accuracy measurements for poll loads, and that I think all that spacing related stuff from pass-fail perspective will be enabled with this new hardware. So if that's of interest, we're happy to talk about it. We'll be doing projects with other customers next quarter with that.
Okay. Thank you. Carson, man, I'm going to get myself in trouble here. I think I know the answer to this one. Someone had asked if you were doing some things on transmission lines, but I think that proof of concept was more around distribution. Is that correct? Or are you doing some stuff around distribution?
Yeah, IMAP is distribution only. Our transmission team is doing something very similar though, not necessarily with Noteworthy, but they have a similar pilot program.
Okay, well, we're going to go back to Joanna. And so if you want to transfer learning to fine-tune an existing deep learning package, how easy is it to change the existing script?
I can't speak on the deep learning package. This does not use any of Esri's pre-trained deep learning packages. But for this script, to modify it, it is actually pretty simple. Everything's based on your parameters, so you can enter if you wanted to use a different field name, a different attribute. It's all very simple to change. But I can't speak to the deep learning.
And I can
Okay.
add on that. I can add on that, Todd, for
Go
that
ahead.
part. The transfer learning tools, those all exist inside of our tooling within our GIS. One thing that I like, is Joanna showed all of this being done in Python, and I found that doing that workflow for like the transfer learning or even just AI detections in general works really well in that. So as she mentioned, it would be a simple add of that code block in where you're taking the input deep learning package, adding your samples, reiterating that training, getting your metrics, and saying, okay, is this where we want our specs? And then once you're happy with it, then you just plug it into that script, and then you can continue the downstreams. But now you have some additional analytics done there too.
Okay, great. Joel, you're up next. So, so for the mounted cameras, are new pole locations taken using offset calculations real time, and how accurate are the results for the location?
Yeah, so we're fully, edge capable on this hardware itself. So there we have NVIDIA chips running on our CPUs. There's a lot of analysis and algorithms that we have built in on the edge to help with those pole locations. So it's taking into account the direction the vehicle's heading, the speed of the vehicle, and then we're determining based on that stereo camera how far away that pole is. And in many cases, we're actually reflecting much more accurate locations for those assets than what the utility may have in their records already. So not only finding missing poles, but then helping get those pole records more accurate. Our typical margin of error is 1 to 2 meters. We have quite a few that are much less than that. And so when we're collecting data, it's always up to the customer when they want to actually update the record on their side, but we'll do a spatial join based on the records they share with us and tell them, these are all matched poles. They can go through and do a quick review to determine which one's more accurate to the actual pole placement, and if it's appropriate, update that record. But we typically are within 1 to 2 meters, and that's based on all those offset calculations happening on the edge.
Okay, cool. Okay, Carson, people are ready to get after your transmission and go off-road, it looks like. They're asking if camera inspection is available for ground-based off-road vehicles. And that might be...
I can
from
jump
Joel
in
too.
if you want, Carson, as well. So
Okay.
the off-road comes up quite a bit. Technically, all we need is a appropriate roof to mount to and a power source for the camera. So there would be a number of UTVs that I think would be good candidates for us to do off-road collection. I am hoping I get a customer soon that actually, says we're ready to do that project, because we've had that question come up quite a bit. It's not something we've done to date, but I'm confident, we'd be able to collect rear lot assets that way as well. We also have some mobile collection features, not a full field app. There's a lot of great tools that are out there for full field apps, but we have a mobile collection tool where you can just walk up and take a picture with your phone of the poles as well. So a couple ways to get rear lot assets, really focused on the distribution side where you've got, off-road assets, some of the more rural service territories.
Okay, good. So back to Joanna, this is all about scale. And so what kind of imagery volume have you added to this feature service so far? Like, are you encountering any performance issues exposing your imagery in a web experience?
That's actually a really great question and something that we've been looking at too. Performance has actually not been an issue yet, but we are still in the early stages. This is a pilot program. We have maybe 500 photos that are being exposed in that web experience right now. Major thing here is limiting the map extent, because if it's going to try and load all those images at one time, you will encounter poor performance. But I have the scale set so they are not going to show up from way out here. And another thing, if we do add more photos and this volume continues to increase, it would just be probably turning off that extent-based photos and just doing like a filter for this specific structure, and then you see all those photos. That is going to enable even better performance.
Okay. And I'm juggling Q&A and chat, which is why if you guys can, please put it in chat for sure. And we will be sharing a copy of this recording. We'll put it on both our community, and everyone who's registered will get a copy to be able to see the recording as well. There's a question about including thermal imagery. Is that something that's being looked at by any of your utilities or with you and your solution, Joel?
So I mentioned already, our next generation hardware has been in development for a little bit. That release is going to add lidar along with the imagery, and that's our primary focus right now from a product roadmap. Is enabling both the hardware and the software features for that. We absolutely have thermal as something that we keep an eye on and would consider in the future if it's appropriate. No time horizon on that at the moment. I think, in a lot of ways, what we do is complementary to thermal capture, and in a lot of cases provides more proactive intelligence than the way thermal is done today, at least primarily. If you think about a thermal program, it's often doing sort of a point in time exercise based on whenever you were able to get the vendor scheduled to go out and collect the data for you. If it's a mid-July day and it's 94 degrees out and humid, you're probably going to get some great insights into where your hot spots are because of the peak demand. But, if you end up on the schedule in mid-April and it's 65 degrees and mild, you're going to have a lot of intermittent spots that aren't necessarily visible on those conditions. Whereas what we're doing, Carson showed some great examples of, transformer damage, different things like that. If we see a leaking transformer, that may not be a hot spot on any given day, but it is a hot spot at least some of the time because of the degradation of the condition. So if we're able to find those things more proactively, I think it makes it easier to take preventative measures before they could be potential outages. So we're trying to be as proactive as we can with the insights we deliver. I think ultimately, thermal something we'll continue to keep an eye on. And today I'd say it's largely just a complementary tool in the toolkit, so to speak. So.
Okay, we had another one come in and we have a few minutes left here. We'll take a few more questions if anybody has them. But the one we're going to answer now is, do you have anything like a camera that's stationary that might get mounted in a substation, or are you mainly on vehicles?
So we're focused just on doing roadside assets, vehicle accessible assets, really on the overhead distribution side. Like we could get into more specifics of what else is out there in the broader ecosystem. I think there are a lot of really complementary tools out there, drone programs, I think those, we enrich each other when we can work together. And I'd say similarly for, substation solutions, that's not something we focus on today. But, I think there are, some really interesting tools to help on the substation side as well.
But that might be something that would complement and come into your system and be able to augment potentially and some of the other stuff they're doing.
Absolutely. And I think one of the other things, within the context of IMAP and our Esri partnership, we're not necessarily trying to be the single pane of glass that you manage these assets from. I think, what our primary focus is on is how do we enrich and accelerate how quickly you get those insights and how frequently you can refresh them, because you've already got some really capable systems, from really established service providers. They're just waiting for the right data to go in there to make it more actionable. And so if we can play a role in accelerating that throughput, it makes everybody's jobs easier because they're already logging into those systems and counting on the data in those systems already.
Sure. Well, with that being said, Tom, did you want to close this out with any final thoughts from an Esri perspective, or we're going to wrap things up?
No, I guess, first of all, I really appreciate everybody's time. And this is obviously a very critical topic in the electric industry. And there's a lot of things that are happening and new innovative approaches that are already being leveraged. So we're always happy to answer questions. Really appreciate your time today and look forward to follow-up questions and ideas from both customers and the vendors that are part of the UIGA membership. So this was, I think, very informative, and really want to appreciate everybody's time today.
Yes, thank you so much, and thank you for making this possible. This is number 2 in a series of 4, so we'll have 2 more upcoming webinar sessions. Be on the lookout. We'll let you know about those being available. And if you missed the first one, it's on our community. We have a recording there, and we have one more question. I think we have a minute, so let's do it. Did somebody raise their hand? Oh, that was a mistake. Okay, I think we're wrapping up. Thank you so much, everyone, and we'll be in touch about the future. And we will absolutely share the link to the video to everyone so that you can see the first series and sign up for more. Thank you so much,
Hey, Todd.
everyone. Bye-bye.
Todd, I'll quickly
Oh, yeah.
add, if there's any other questions and you put them in the chat, we'll also follow up with answers for
For
those.
sure.
Yep.
Thanks, everyone.
Thank you, everybody.
Thank you,
Bye-bye.
everyone. Bye.
Thank you.